Algebra 2 Skills number 8, solve by factoring. This time we have a leading coefficient up here in front of x squared, so it makes it a little more difficult. Let's take a look. Alright, so there are several ways of factoring when you have a number in front of x squared for a trinomial. There's some ways that are kind of gimmicky and hard to understand exactly how they work. So we're going to use the split the middle term. There's two reasons for that. Number one, it makes sense how it works. But also, number two, it helps us with the factor by grouping process that we'll see later. So that's one reason why, or a couple reasons why we choose this process. So the zero product property, if you have two things which multiply together to give you 0, then that's only going to be true if one of these terms equals 0. Okay, you can't multiply two non-zero numbers together and get a zero product. So if we can make it to where it's two things multiply together and it equals 0, then we know that one of those two factors has to equal 0. So first example, this is going to be a very colorful example. Hopefully it's not too colorful, but we have a number in front, this 4 here, which prevents us from immediately asking ourselves what multiplies the negative 9 and adds negative 16 that we would ask had there not been a 4 there. So it's a little more complicated. So what you need to do then is to multiply the 4 times the negative 9, and 4 times negative 9 is negative 36. And you're actually looking for factors of negative 36 that add to negative 16. So let's see what the next line looks like. So a lot happened here. 4x squared was retained. The negative 9 was retained, so you can see with the color coding. But we took this negative 16 and we turned it into negative 18x and positive 2x. So notice that the purple terms here, negative 18 and 2, still add to negative 16. So this is mathematically the same thing. It's equivalent. And where 18 and 2 came from is the fact that those are the factors of negative 36 that add to negative 16. Again, negative 36 coming from 4 times negative 9. So you have to multiply those two, write it in the margin, ask yourself what multiplies to this margin number but adds to the middle number. So that margin number actually doesn't show up a lot of times in the problem. Notice also our formatting. We group the first two together and group the second two together. Okay, from here we're going to take out GCF. So again, a lot of colors here. I took out 2x from these two because 2 is the largest number that goes into 4 and 18. I can take at least one x out of each term. If I were to divide these two by 2x, I would get 2x minus 9. 4x squared divided by 2x is 2x. Negative 18x divided by 2x is negative 9. If I do the same thing over here, what's the biggest number that goes into 2 and 9? Well, there's not one really, it's just 1, so I wrote that out there. And there's no x here, so I can't take any x's out. 2x divided by 1 is 2x. Negative 9 divided by 1 is negative 9. Okay? And the reason it's so colorful is because, well, it kind of helps us see what happens on the next step. Notice that this orange here is a matching parenthesis. So 2x minus 9 is now kind of like the GCF of these two big terms. You've got this term and this term, so I can take a 2x minus 9 and the orange part out of that. And if you do that, if you divide this part by 2x minus 9, you're left with the blue 2x. And if you divide this part by 2x minus 9, you're left with the blue 1. So notice the colors here as you go. There's quite a lot there to digest, and we'll certainly see another example. But here we can take advantage of the zero product property. I have two things multiply together, which gives me 0. So let's take all the color coding off right here. I set 2x minus 9 equal to 0, and I set 2x minus 1 equal to 0. And I solve those. Okay, so again, in Algebra 2, I didn't show every single step here, but if you add 9 and divide by 2, you get 9 over 2. You just leave it like a fraction. If you add 1 and divide by 2, you get 1/2. So a lot of times you'll just see it written x equals 9/2 or x equals 1/2, and you'll often see them collected in a solution step with the braces and put in ascending order. So 1/2, 9/2 like this is also a common way of expressing your solutions. So if I plug either number back into the original and for the x's, I will get a true statement. So let's look at a second example. This time I'm not going to color code it. But 6x squared plus 19x equals 11. Like before, if you have a quadratic equation that you feel like will factor, you're definitely going to want an equals 0. So I subtract 11 from both sides to get that. Now remember what we did. 6 times negative 11 is negative 66. I put that in the margin. what are factors of negative 66 that add to 19? And you're probably writing this in the margin and thinking about it. Well, it ended up being 22 and negative 3. Okay, so again, I separate those. I retain the 6x squared. I retain the negative 11. But I take the 19x and I split it up into 22 and negative 3. And 22 and negative 3 again comes from the factors of negative 66, which are those two multiplied together, that adds a 19. A common mistake I see here is to neglect writing the x. A lot of times people just say 22 and negative 3, but you do need the x's in there because remember you're adding to 19x. So think to yourself here, what's the GCF in the first term and what's the GCF in the second term? Remember, you want these parentheses to match. Okay. 2x is the GCF in the first term. 6x squared divided by 2x makes 3x. 22x divided by 2x makes 11. And a quick check here, you can always distribute in your mind and think to yourself, if I distribute here, do I get this back? Also look and make sure that this has nothing other than a 1 that you can take out. If it distributes back and this is what we call relatively prime, there's nothing you can take out of it other than a 1, then you know you've done the right thing. Now here, notice that 3x plus 11 and negative 3x minus 11, they nearly match, but they're off by a sign. So sometimes you have to take a negative 1 out. If I divide both these by negative 1, I get positives, and now they perfectly match. This is a good thing. So like before, we had these matching parentheses, which is the 3x plus 11. I wrote it in different order here just to illustrate. It doesn't really matter the order. 3x plus 11 comes out from these, and you're left with a 2x minus 1. And now we have the zero product property, a times b equals 0. So either a equals 0 or b equals 0. And then I just solve those. Again, Algebra 2 here, we're not going to show every step. But add 1, divide by 2, subtract 11, divide by 3 to get your two solutions. So that is solving by factoring when the leading coefficient is not 1.